Hi, I'm David Vargas,
And I'm Tej Joshi.
and our topic is factoring polynomials. First, we're going to start with factoring binomials. Binomials are expressions with two terms. Let's look at our first example. 24x squared plus 18x. The first step into factoring binomials, you have to find the greatest common factor. In this case, it's 6x. When you divide the greatest common factor between the two terms, you get 4x plus 3. Let's go to the second problem. 81y cubed plus 27y squared. The greatest common factor here is 27y squared. Again, you must divide that greatest common factor between the two terms to get 3y plus 1. The last term is 1 because 27y squared, the greatest common factor, is the same thing as the last term, so you get 1. The last example, 56b to the 1/4 plus 49b to the 1/2. The greatest common factor is 7b to the 1/4. When you divide that between the two terms, you get 8 plus 7b to the 1/4. You get the last term because when you multiply, you keep the base and add the exponent, so you get the b to the 1/2 in the second term. Next, we're going to talk about factoring trinomials. When you factor trinomials, you have to split it up into two binomials. Let's look at the first example, x squared minus 7x minus 18. You have to find two numbers that add up to negative 7 and multiply to be negative 18. Two numbers that do that is negative 9 and positive 2. When you add up negative 9 and positive 2, you get negative 7, and when you multiply them, you get negative 18. So the answer is x minus 9 times the quantity of x plus 2. So look at the second example. X to the 1/2 plus 3x to the 1/4 minus 4. You split it up to two binomials starting with x to the 1/4. Because when you add x to the 1/4 times x to the 1/4, you keep the base and add the exponent to get that x to the 1/2. The two numbers that add up to positive 3 and multiply to be negative 4 are positive 4 and negative 1. So the answer is x to the 1/4 plus 4 and x to the 1/4 minus 1. Let's look at the final example. The quantity of a plus 2 squared minus 12 times a plus 2 plus 32. It looks complicated at first, but if you sub in a plus 2 as x, you look at the equation as x squared minus 12x plus 32. When you factor this problem, you get x minus 8 times the quantity of x minus 4. Now we can sub in a plus 2 back into the equation. So we get a plus 2 minus 8 times the quantity of a plus 2 minus 4. Our final answer then is now a minus 6 times the quantity of a minus 2. Now we're going to talk about the difference of two squares. When you have a binomial and each term is a perfect square, you can split up the binomial into two more binomials. Let's look at the problem of x squared minus 64. When you square root each term, you get x and 8. So the two binomials, each term has to add and subtract from each other. So you get x plus 8 times the quantity of x minus 8. Let's look at the next problem of x to the 4th minus 81. The two squares are x squared and 9. So you get x squared plus 9 times the quantity of x squared minus 9. But this problem can still be factored even more with x squared minus 9 because the square root is x and 3. So you have x squared plus 9 times the quantity of x plus 3 times the quantity of x minus 3. Let's look at the last example of 81x to the 8th minus 16x to the 4th. These two terms have a common factor of x to the 4th. So you have to factor that out, and you get x to the 4th times the quantity of 81x to the 4th minus 16. You then factor the 81x to the 4th minus 16 because there's a difference of two squares. So it becomes x to the fourth times 9x squared plus 4 times 9x squared minus 4. But the 9x squared minus 4 can still be factored to become x to the fourth times 9x squared plus 4 times 3x plus 2 times 3x minus 2. Now we're going to talk about the difference of two cubes. When you have a binomial and each term is a perfect cube, you can split up that binomial into a binomial and a trinomial. Look at the formula. A cubed plus b cubed equals a plus b times the quantity of a squared minus ab plus b squared. A cubed minus b cubed equals a minus b times the quantity of a squared plus ab plus b squared. Let's look at the first example. X cubed plus 64. When you find the cube root of x cubed, you get x, and when you find the cube root of 64, you get 4. So a equals x, and b equals 4. So you just sub that into the equation. So you get x plus 4 times the quantity of x squared minus 4x plus 16. Let's look at the second example. 27t to the 6 minus 8. When you find the cube root of 27t to the 6, you get 3t squared. And when you find the cube root of 8, you get 2. You sub those two back into the equation, and you get 3t squared minus 2 times the quantity of 9t to the 4th plus 6t squared plus 4. Let's look at the third example of 64y to the 4th minus 27y. It has a common factor of y, so you factor out y to get 64y cubed minus 27. When you find the cube root of 64y cubed, you get 4y. And when you find the cube root of 27, you get 3. So when you sub it into the equation, you get y times the quantity of 4y minus 3 times the quantity of 16y squared plus 12y plus 9. Next, we're going to talk about factoring by grouping. When factoring by grouping, you can either group in pairs or group as difference between monomial and perfect square trinomial. First, we're going to talk about group in pairs. You can take the first two terms and factor out a common factor as a and leave x plus y, and take the second two terms and factor out a common factor as b and leave as x plus y. You have to make sure that the binomials that are left are the same, because when you factor out x plus y from the first two terms, you get x plus y times the quantity of a times a plus b. Now let's look at group as difference between monomial and perfect square trinomial. As you look at the first three terms, it's a perfect square trinomial. When you factor that trinomial, you get x plus 1 squared minus b squared. This is also a difference of two squares. So you do x plus 1 plus b times the quantity of x plus 1 minus b. Let's look at the first example. This is a group in pairs problem. From the first two terms, you factor out 3a squared to get 4a minus 3. And the second two terms, there's nothing to factor out, so it's 1 times the quantity of 4a minus 3. When you factor out 4a minus 3 from both terms, you get 3a squared plus 1 times the quantity of 4a minus 3. Let's look at the second problem. X squared minus 6x plus 9 minus 4b squared. The first three terms is a perfect square trinomial, so it becomes x minus 3 squared minus 4b squared. You then take the difference of two squares, which is x minus 3 plus 4b squared, plus 2b, times the quantity of x minus 3 minus 2b.